So if you were gone yesterday, maybe skip down to the very bottom of the page, or you might just be able to start on the new page and just write a little smaller. We have this last part here that we're going to fill out, and then we have one more page here. So what we're going to do is you at your tables have these little clippies, these little plastic things. So everyone grab 2 of them, doesn't matter which colors. Just grab 2. We'll connect them, and that makes our angle. So this is our visualization of an angle changing. It gets smaller, smaller, smaller as it closes. And then it gets open, open, open. Once it hits that 180, well, clip it in. Oh, clip it in on the other side maybe. Switch sides. Sometimes there's like little plastic pieces that didn't get in there. All right, so that's our angle. Good. So everyone change yours to 90 degrees. Everyone make a 90-degree angle. Let me see what you got. Perfect. Beautiful. 90-degree angle. Beautiful. 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 Amazing. Make a 90-degree angle. Amazing. Okay. Now, if you have enough, you can grab 2 more pieces. Make one more angle. So leave that one at 90 degrees. And then make one more angle. And this time, we're going to make this angle 45 degrees. So we can envision that idea that this is 90 degrees here. And then we're going to think about finding it about that halfway in between. So about 45 degrees. Try and find that. Good. Yeah, some people just grab one extra one and just put it on the top. Beautiful. Beautiful. Good. Awesome. You guys are out pieces? Oh, sorry. Can I borrow this one? Thanks. Here you go. Awesome. Nice work, you guys. All right, we're going to draw an angle. We're going to draw angle. PTS so that we're going to do this little m, this lowercase m, and then that angle sign again. And what that means is when we see that lowercase m and that angle sign, it tells us the measure of the angle. Okay, remember how we have with the segments, we have AB with the line to actually cross it, and then we say AB with no line. And the AB with no line means measurement. Same thing here. This is going to mean that we're measuring it, and remember we measure angles in what? Inches, centimeters, degrees, years, seconds, degrees. So we're going to do it so that the measure of angle PTS is 78 degrees. And we're just going to estimate. We do the blah, 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 words. They do sell protractors. Protractors are like what's on the floor outside my door. If you see the blue stickers, that's like how you measure exact angles. We're just going to estimate. So to start off with, we'll have one ray. A ray is where we have that side. It has an end point, goes to another side. All right, so for 78, right now we have our 90 and our 45. Where is 78 going to be located between? Like, how would we visualize 78 degrees? So as I move this is 45. I'm going to take my 45 angle. I like to just keep this 91 below it. Some of you were just able to attach it right on. That's awesome. As I take that, am I going to close the angle more or open the angle more to get to that 78? Right now it's at 45, so should I open it or close it? Open it, good. And am I going to open it all the way to 90 degrees? No, so you kind of have to think, okay, this is 45. So this is maybe like 50, 60, 70. That's probably about close to 80. Just a little bit shy. 78 is close to 80, so about there. So that's what we're going to try and draw, is that angle. Some people, they like to actually trace it. I'm going to try and draw it as best as I can. I think this is 90. I want it a little bit less than 90. All right, a couple of things we need to do. We need to name this, or we already have the name. It's PTS. We need to figure out where those points go on this angle. T goes where? In the middle, good. What do we call that middle point again? You need to look up. It was from yesterday. The vertex, good. The middle is the vertex, so T goes in the middle. And then does it matter which side is P and S? No. So P, T, S, or you could have done S, T, P. And then because we just estimated it, we're going to tell our reader it's 78 degrees by putting that measurement right in that angle, 78 degrees. Okay, but when we draw angles, do we always have to have a horizontal line in our angle? No. So if you did yours with your ang legs, these are called ang legs, called angle legs, okay? If you have your ang legs, try rotating it and think about trying to draw that maybe at a different angle. Whoa, drawing an angle at a different angle, different rotation. So think, once you have that first line, you can think of where that 90 degrees is, and we're going just a little shy of 90 degrees. Okay, angles can be in any direction. When I draw angles, I generally draw it with that horizontal line. It gives me a better vision of it. Okay, again, what has to be our vertex, our middle point where they come together? T. And then our other two? P and S. Doesn't matter which one's which on that one. If you already labeled yours, do you put P here and S there? Perfect. All right, and again, we'll throw that 78 degrees in the middle. And that just tells our reader that, hey, we probably didn't use actual math tools to create that 78 degrees, but we meant it to be 78 degrees. All right, I'm going to move to the next page. I'm out of space. All right, our next word we have is congruent angles. This one's really important, so I'm going to underline it. We're going to use this a lot. Congruent angles. We talked about congruent segments when we did 1-2. What was congruent again? Equal or the same. Good. So congruent angles are angles that have equal angles that have equal measures. All right, let's create an angle that's a little bit bigger. Let's do like a 120. So if I have a 90-degree angle and I'm visualizing that 120, am I going to open the angle or close the angle for 120? Open. And I know this is 180. So is 120 going to be closer to the 180 or closer to 90? Where does 120 fall in between 90 and 180? Which one is it closer to? It's only 30 away. It's kind of close to the middle, but it's technically a little closer to that 90 degrees. So here's our 120. Okay, so we're going to draw that here at 120. We'll put those 3 points on there. All right, we're going to call this one, we'll have N as our vertex. And then for our other 2 points, let's do A and K. Okay, that's about 120, so I'll just write that 120 somewhere in that middle, about 120 degrees. All right, now if I flip it over, did I change the measurement? If I just flip it this way? Nope. So let's try and draw it that way. Okay, but this time we're going to name it a different angle. This one, the vertex is going to be J. And then our other 2 points will have a C and an E. And again, that one was a 120 degrees. So we're not just copying the same angle. It's technically a different angle, but they have the same measurement. So the way that we show that, to show that they have the same measurement, if we don't see that 120 there, another way to do that is by using a symbol. When we did segments, remember we used those tick marks to kind of show matching. Okay. With angles, we use these little, I call them arcs, or some people call them like swoops, but we do a little swoop in the corner here. Okay, if you want to use a colored pencil, you can, to show that was a big idea. And then I'm going to do a swoop on the other angle to show that those match. So anytime we see these arcs or we see these swoops, I call them swoops, arcs, I call them arcs usually. Anytime we see those arcs, that tells us that they're matching. They go together. Okay. Another way that we can write it out is by using that congruent symbol. So we're going to name these angles. What's this first angle called? How would I name that one? Good. I could do A and K or K and A. Good. I'm going to go with A and K. That's the way my brain reads it. If you first looked at it and you said K and A, that's fine. What has to be the middle letter? N has to be the middle. Then we're going to do that congruent symbol. So remember, that's an equal sign with a little squiggle above it. So angle A and K is congruent to angle, what's our other angle name? CJE or EJC, either one. Again, my brain just reads it as CJE, so I'm going to keep it that way. CJE. All right, we have a couple more words. It's just a lot of vocabulary today. It's kind of insane. You guys are doing great. All right, next up we got an angle bisector. Angle bisector. We talked about segment bisectors. Again, that was on 1-2, where we talked about, actually that was 1-3. We talked about segment bisectors. What is that bisector? What did that word mean again? Two, yep. And the two parts are equal. It just means we're cutting something right in half. So an angle bisector is something. Could be a line, it could be a ray, it could be a line segment, it could be a plane technically. Something that cuts an angle into two equal parts. Something that cuts an angle into two equal parts. All right, so if I have JP, ray JP, bisects angle TJM. We're going to draw that out. JP bisects angle TJM. So when you cut something in half, do you just start cutting random things and hope to get half? No, first you start with the thing you're cutting, right? You hold the piece of paper you're cutting, or you hold the piece of string you're cutting. So we're going to start by drawing our angle, TJM. Bless you. Okay. Can be any type of angle here. I'm going to go with a little bit of an acute one, kind of a smaller one. Okay, on our angle we need 3 points. What are my 3 points going to be? T, J, and M. Good. And the one that's really important is J has to be the middle or the vertex. Good. I heard somebody whisper it. Okay. The other ones can just be T and M. Doesn't matter which one you put where. I'm going to do T first and then M. All right. Now we have a bisector. We're going to have J to P. And that's a ray. So it's starting at J. And it needs to go through P. Where is P going to end up being? Yeah, somewhere inside. It's going to have to be inside somewhere. So we're going to have to think about where would that line go to cut it in half. And if you visualize this, here I have TJM, looks something like that. And I'm thinking about where does this one need to be in between so that the two spaces end up being equal. So that's kind of how we're figuring that out, is where can I put that line so it goes right in the middle as best as we can. So it cuts it in half. Again, as best as we can. We're not actually using measurements here, but we're doing as close as we can. All right, and what's our extra point that we'll put on that ray? P, good. I was going to say J, but that was wrong. All right, because it cuts it in half, we have 2 parts that are equal. What's another word for equal parts? Congruent, good. So I'm going to show that they're congruent by using those arcs. If you want to use a colored pencil, you can. I'm actually going to use a pencil for this part. Okay, so for our arcs, we do that little arc, that swoop. I'm going to go from that green to the blue. And sometimes if we have lots of angles in our picture, we'll use 2 arcs. So that way the 1 matches with the 1, the 2 matches with the 2, the 3 matches with the 3, so on and so forth. And then I'm going to do 2 arcs here. Now when they're next to each other, sometimes we like to stagger them so that they don't look like they're all one thing. So kind of in a way where they don't quite look like they match up. That wasn't a very good example. There we go. Okay, if you had yours matched up, that's fine. Just sometimes it looks like it's one continuous arc. But then again, we just match the two arcs with the two arcs. So if JTP is 22 degrees, nope, 28 degrees. There we go. What's PJM going to be? 28 degrees. The other side would be 28 degrees. How much is the whole angle TJM going to be? How'd you get 66? What? 56? How'd you get 56? Good. We added 28 plus 28 is 56 degrees. All right, last part we're going to add to this, and then we just have a couple quick things. All right, angle. What's that one? What's the smaller? We're going to name the, sorry, ring. We're going to name the congruent angles. So what's one of the congruent angles called? What was one of the smaller angles, the 28 degrees? We start with T. We could do T to what? J. And then we're doing that 28 degrees. So do I want to go over to M or up to P? P. So TJP, angle TJP, is congruent to angle, what's the other one going to be called? PJM or MJP, either one. I'm going to go with MJP just to switch it up because that's not how I normally do it. But just to remind myself when I look at my notes, it's okay to switch it up. All right, we have one more thing, and then we're going to do just a really quick little diagram. All right, we're going to classify some angles. And these are words that, again, you probably heard way back when we talked about angles. It's probably been a couple years. I used one word earlier today. All right, so for classifying angles, we're going to start with a right angle. So how many degrees is a right angle? Mm-hmm. 90, yeah. So right angle means it's exactly 90 degrees. If I draw it again, that looks kind of like that L shape. But what symbol can I put in that angle to show it's exactly 90 degrees? Got that little square, the little box in the corner. All right, what's another way we can classify an angle? If it's not right, it could be acute. Does anyone remember what is acute? Smaller than 90, good, or less than 90? Okay, so we're doing a smaller angle. I always think of it as like it's a cute little angle. It's a cute. Because when people are small, they're cute, like me, right? Because I'm small. Lukeman just rolled his eyes at me. It's fine. If I was an angle, I would be an acute angle. Because I'm a cutie. All right. You know what's true, Camille? All right. What's the other word that when it's more than 90? Obtuse. Good. Obtuse is more than 90. if you're arguing, this isn't something that's said very often anymore, but somebody might say, oh my gosh, how could you be so obtuse? Obtuse means like you're so far off the right path. Okay, right is 90 degrees, so obtuse is like you're so far off, you're veering off. So obtuse is we have that bigger angle. So if anyone ever calls you obtuse, they're not calling you big, they're not calling you more than 90, they're saying you're wrong. That you are so far off right. All right, we have one more, and this is a straight angle. Okay, and a straight means that it looks like I have two parts. I'm going to use those ang legs again. So I have a purple and an orange, but they end up looking straight. So it ends up looking like a line. So it's exactly how many degrees? 180. And what's goofy about it is we call this, it's another way to say opposite rays. Another way to say it is opposite rays. Because it's not like we're just taking, the visual of it is we're not just taking like this yellow and saying, okay, look, it's a straight angle. Technically it is a straight angle. But it's like we're connecting two parts, and then we're making them go in opposite directions to make that. So it's like I'm starting at this point, and I have one ray going this direction. And then to make a straight angle, the other side is going to go in the opposite direction to make that 180. How are we feeling? A little bit like this was review? A little bit like a little couple new things? Good. All right, we're going to end there today. There is a practice. It's in Schoology, week 2. I want to give you enough time to get started on that practice. Something you're going to see on the practice that we didn't do, I'm going to give you full disclosure because you're going to be like, we didn't do one of these in the notes. You're right. There's going to be a couple where it's going to ask you how many degrees something is, and you might have to figure it out. Like if it's a 90-degree angle and you know one part is 60, what's the other part going to have to be to make 90? 30. Things like that. Okay, it helps to draw it out. You're going to see that word bisector. That's usually the one that most people struggle on this practice, is the one with the bisector. So use your notes, maybe keep those out. Practice is in Schoology, week 2 folder. Rest of the time is for you to work. If you're working next to a